Okay, I'm going to start out demonstrating this software by doing a problem in section 8.1 on page 306, problem number 6. It says Nielsen Media Research conducted a study of household television viewing times during the 8 p.m. to 11 p.m. time period. The data contained in a CD file is going to be used to estimate the population average number of hours per week that people spend watching television during that 8 to 11 time period. Now, this was an Excel file that I had to get from the CD, load into my computer, and use descriptive statistics to get the values. The sample standard deviation turned out to be roughly 3.5, and I'm going to use that to estimate sigma. And if I call that sigma, it's really a planning value. It's not sigma, but it's an estimate. You know, if we actually knew what sigma was, we would have had to have known the population average, and if we would have known that, there's no point of sampling at all. So, at any rate, we're going to use 3.5 to estimate sigma. The sample size was 300, which is large enough, in other words, greater than 30, to know that any sampling we do, the sampling distribution is normal. And might as well go ahead and calculate the standard deviation of the sampling distribution, which is called standard error. And it's taking the population standard deviation, or estimate of it, divided by the square root of the sample size. So putting our values in there, I have 3.5 over the square root of 300, and that calculates 0.202. Now, what we're trying to estimate is the population average. We don't know what the population average is, but we have a sample size 300, and the average on it is 8.5 hours. So that'll be our estimate. We'll estimate that the average number of hours per week that people watch television during that 8 to 11 time period is roughly 8.5 hours. That's our point estimate. What a confidence interval does is it helps us know how good an estimate that is, or how far off it could be. And using the formula in the book, we'll calculate a 95% confidence interval. Our x bar is 8.5. That's our estimate of what mu is. And we want a 95% confidence interval. Remember, the empirical rule said that approximately 95% of the data in a data set fall within 2 standard deviations of the mean. So approximately 95% of the sample averages will fall within 2 standard deviations of the mean. More precisely, it's 1.96 standard deviations, which we've already calculated as 0.202. And then we can go ahead and calculate the product there, 1.96 times that, or roughly 2 standard deviations of the mean, as being 0.396. 0.396 hours. Now I want to stop there just for a minute and look at that 0.396. This is called the margin of error. The margin of error. And it's pretty much telling us how close our 8.5 estimate is to the real value. I'm 95% sure that the real population average amount of time is within about 0.396 hours of my estimate, 8.5 hours. Or my 8.5 hour estimate is within 0.396 hours of the real population average amount of time that people spend per week. Now that 0.396 hours is roughly 24 minutes. If you take 0.396 and multiply by 60, you'll get roughly about 24 minutes. So my estimate of 8.5 is within about 24 minutes of the real value. And that gives me a feeling for how good the estimate is. I'm going to go ahead and calculate the interval just by adding and subtracting the 0.396 to the 8.5. And on the lower end, I get 8.104, and on the upper end, I get 8.896. So in conclusion, with my 95% confidence interval, I can say I am 95% confident that the real population average number of hours watched per week is somewhere between 8.1 hours and 8.9 hours. I am 95% confident or sure that the real average number of hours people watch television per week between the 8 to 11 p.m. time period is somewhere between 8.1 hours and 8.9 hours. My best estimate is 8.5 hours. My confidence interval tells me how close that is, basically, to the real value. That the real value is somewhere between 8.1 and 8.9. I'm going to estimate it at 8.5.